Just hello everyone. We're just doing the mic testing. Just want to check the sound. Is the sound all right? If the sound is all right, then I'll get started. So I'll just wait till my team confirms that the sound is coming well. Otherwise, meanwhile, you can. Okay, cool. We got a thumbs up from the sound. Brilliant. Okay. So hello everyone, and welcome to day 3 of our webinar. So we've day 3 in the sense the third day of live coverage here. We are going to cover day 9 and day 10 today of the daily coding challenges. I'm going to wait about 2-3 minutes more till everybody joins in because I've started a minute early today. So I will just wait a minute more till more people join in. It's about, yeah, so it's 8 o'clock. Today is our session for this. And yes, welcome all. Today we are discussing about these things. So today, sorry for that. Yeah. All right. So today we're discussing April daily challenges, day 9 and day 10. So just to recap, Edyst did April daily challenges. That is, every day for 10 days in April, we would release one daily challenge, and then depending on who was able to solve all the 10 first, we announced the prizes, and everybody got it on the leaderboard and so on. So today is day 3. Today is day 3, or that today is the live coverage day. All the 10 days have already ended. Day before yesterday, that is the 23rd of April, we discussed all of the questions from day 1 to day 5. The link for that can be found in the description. Day 6, day 7, day 8 we discussed yesterday. That was the 24th of April. And then the 25th of April, that's today, we are going to discuss the remaining questions. We won't be taking too much time today because both those questions are not too difficult. They just require new concepts, and I won't be teaching those concepts, but I'll tell you where you can learn those concepts and where you can pick those concepts up from. Okay. Alright, so with that introduction, we'll get started right now. Good to see people already online. Robish is online. Hi Robish, how are you? Glad to see you online and coding on a Saturday evening. Before I start, please make sure that you subscribe to this channel and share this channel with your friends if they are interested in coding and learning about placements. This will greatly help them. I am also happy to mention that we've reached 13,000 subscribers, so keep the subscriptions coming in, and yeah, we should touch new milestones soon. All right, so I'll get started right now. This is the leaderboard of the 10-day challenge. Again, a huge congratulations to all 10 of them for spending the 10 days, getting up on time and finishing the challenges. It wasn't easy. I know it wasn't easy. It was difficult, and congratulations once again to all 10 of you. This is what consistent practice can get for you. Before I start 2-3 announcements for everybody. Number one, Code Vita round, so Code Vita 2020 is going to come up pretty soon. This is just basically the dates that you should take up. So 10th of July to 25th July is the first round, and then the second round will be this one. Last year, even if you cleared the first round, even if you cleared the first round of Code Vita, you were getting called for an interview. I have known many students who cleared just one question and were still able to get an interview with Code Vita and actually got a job at TCS. Sorry, not Code Vita, TCS. So this is there. Like that, last year's in 2019 we had more than 250 selects in Code Vita. Overall, Code Vita had many more selects, but from Edyst specifically, we had these many selects. And this year, I'm sure we're going to double that at least. Depends on TCS appetite to hire also. All right, so that's coming up. A lot of people are asking about Code Vita, so I just thought I'd share this part with you. The second thing I wanted to share with you is the other upcoming contests. So one is Code Vita is definitely coming up. The other one is Hack with Infi round 2 is coming up. If you didn't clear round 1, then you can't go for round 2. Many of Edyst students have already cleared round 1, and on popular demand we will be doing a round 2 webinar. So if you want to know when it's going to happen, subscribe to this channel, share this with your friends. You will get the notification on when it's going to happen. Also, if you really want to be updated with all of the Edyst announcements, then find the Telegram link in the description. If you if you don't have Telegram, download Telegram and then find the link in the description. You get all sorts of advantages by being on our Telegram. When we do the daily challenges, we launch sneak peeks on the daily challenges. So we tell students what the next daily challenge, what kind of concepts you should revise for that. It gives you a an advantage and so on. So all our announcements are here. You can quickly join Telegram, and you will find the link here in the description. Lastly, if you are looking to practice for any of the upcoming placement rounds, then Edyst is your place to go. This is just off the top of our head 900 plus students who've got placed just in the last 6-7 months. If you take the entire count, it's obviously going to be higher than this in these companies. So you have like InfyTQ, CodeVita, Salesforce, EPAM, JP Morgan, ServiceNow, AWS, you name it, the companies are there. So if you really want to get started with your placements right now, nothing better than to sign up for an Edyst course, depending on who you are or which level of programming you are at. If you're a beginner, we have beginner courses. If you are preparing specifically for CodeVita or Hack with Infy or InfyTQ, then we have courses for you. So I'd suggest, if you really want to get into it, these are the two courses that you could look into. One is we have a CodeVita 2020 pack. To CodeVita 2020 pack, you can follow this link to visit the CodeVita 2020 pack. If you just want to practice for Hack with Infy round 2, you can purchase this pack. That is a complete coding pack. It has not only Hack with Infy questions, but all the other questions of other companies as well. So you can prepare for other companies. And when you go to this link, we will be updating Hack with Infy round 2 questions also, possible round 2 questions as well over here. Okay, so that is my announcements to make. Just give me a minute. Hold on. I'll just open up the April daily challenges, and then we'll get started with our discussion of day 9 and day 10. 1 second. Yeah, so here we go. So this was the daily coding challenge of April. Okay. Yeah, I got it right. So this is the one. So this was the daily coding challenge of April. This is what you have. And as always, the first challenge was easy. So around 2,100 people solved it, then 1,800 and so on. And so by the time, I think the major drop off was challenge number 6, which is where it started getting difficult. Till 5, we still had 1,000 plus people solving it, but challenge 6 is the one that got difficult. And then challenge 7 was, we discussed yesterday, it took us almost 45 minutes to cover challenge 7 yesterday. So that was the difficult one. But then challenge 8, 9 and 10 picked up. So we have challenge 9 we're discussing today, and challenge 10 we're discussing today. Let's open up challenge 9. It's a question based on Wonder Woman. And really this question is a trick question, in the sense, if you've done maze type of questions before, if you've done 2D array type of question before, then you will actually get confused here if you did not know to think logically. So without further delay, let's get started. So this is a challenge based on Wonder Woman, and there she is. She's unleashing her attack. That's a good movie, Wonder Woman. If you like the movie, you can tell on the chat. So yeah, that was one of the better DC movies. Otherwise, DC movies aren't really that great. Anyway, so this is a 2D array question. Okay, so she's stuck in a 2D maze. And in this 2D maze, what's happening is, so she starts at a position A, let's call it the source, and she has to reach a position B. And we are also given a string of where all she can move. So at any point she can move only 2 directions, and not both of the directions together. So she can move, so for example here, right, we are given that she starts at 1, 1. So this is what 1, 1 looks like. So she starts at A, 1, 1 here, and she can go up till 3, 3. This is where she's supposed to go, 3, 3, okay. 3, 3 is this part, and the only 2 moves she's allowed to make ever is NE. That is, she can either move north or she can either move east at a particular time. She can't do both of them at a time. She cannot move south, she cannot move west. So she can move only N and E. And this is a common theme throughout the inputs. That is, you will first be given vertically where you can move either north or south, and then you'll be given horizontally where you can move east or west. Okay, so let's look at that in the slides for a better understanding of what I'm trying to say. Right, so yeah, so this is what it's like. We have NE, we're told that you can move north and east, and we said we're starting from 1, 1, and we should be going to this 3, 3 position. Okay, so the input in this case would be something like this. Just move this a bit down. All right, so all right, so in this case the input is 1, 1 and 3, 3. So A is A 1, 1, and B is 3, 3, 3, 3, and we're told the other input, that is for the directions, it is NE, right? Now let's look at the first edge cases. Let's say the input was SE. Okay, SE means that anytime I can move either south or I can move east. The problem with SE is from A, I can move east to reach this point, but I will never be able to move, north in order to reach B. So no matter what I do, I can never reach the point that I want to reach. Okay. So for example, if I am allowed northeast, I can southeast, I can move east, and then I can at any point move west only. I can't move more than that. So I can do this or I can't, right? So I can move south only. I can never move north. So that's my problem. I can't move north. That's my biggest problem. So one thing that should be very clear for you is if the y-axis point, or rather the point where I have to reach is higher than the current point, then I need to have a north over here. Otherwise, I can't go ahead. Similarly, let's say if the starting position was 3, 3. So starting position was 3, 3. And ending position was 1, 1. And we were given the input as northeast. So that means I'm starting at B and I can move only north up, or I can move east, right? But I can never move down. So I can never move from B to A. Okay. So this was the edge case here. That is, you have to first check if it's even possible to move from one place to another. So that was a simple edge case. That is, if the X element, so one of the simplest things you could do is you can, so let's, how can we go forward? So basically speaking, if the element, if target is, let's say, if target y, let's say if target y is greater than target x, if target y is greater than target x, then what are we supposed to do? If target y is greater than target x, then we need north. Similarly, target y is greater than source y. So, or in terms of the question, we have if b's y is greater than a y, then we need north. Otherwise, also what we need is if bx is greater than ax, we need, what do we need? We have to go east, right? So we need east, correct? If by is less than ay, right, then we need s, that means we need to go south. So if the target is lesser than that, and if by is if bx is less than ax, then we need to go west, right? Then we need west. So this is the first the calculation that we need to do to even figure out are we going in the right direction or not. So let's say I have the input. A is, I have to start from 3, 4 and I have to reach a B which is 1, 12, right? And I've been told that I can go northeast. Okay, so I can very quickly say that yes, from 4 to 12 north is great, but from 3 to 1 I needed to go west. I can't do anything. So no matter how north I go, I will never be able to reach 3 because it has to be I will never be able to reach 1 because it has to be in the west. So, and I've got east over here. So that was the simple thing to do. Now the real question is not that. The real question is not if I can just go there or not. I mean, Google will not ask a simple question like that. But more important rather is how many are the number of ways that I can reach there. So it's not just about, so I want to start from 1 and 3, 3, and now we have established that you can reach 3, 3 from 1. So if you can reach 3, 3 from 1, the question now becomes how many ways can I reach, right? So I can reach going north, north, east, east, or I can go north, east, east, north. I can go north, east, north, east. I can go east, north, north, east. I can go east, north, east, north. I can go east, east, north, north, right? So there are 6 ways, and if you can find any other way, please tell me. That's it. There are about 6 ways in which you can reach this particular element B from A, right? So just give me a minute, 1 second. So yeah, that's the question. So if I give you a B and I give you an A, you have to find the number of ways in which you can reach. Now, one of the issues I saw students do in terms of solving this question is students automatically assume that this is a normal maze question and then we have to use backtracking, or I have to just use a lot of recursion and backtracking to solve this question. Whereas if you observe the question tightly, right, you will realize that actually it's not even that tricky. So it's not really that tricky. What you really need to do is, let's say I want to go from 1, 1 to 3, 3, right? So let's list down all of the possibilities over here. Okay, so here we had what are the possibilities we got? 1 second. So we had north, north, east, east. So let's start with that. Let's list down all the possibilities. So we have here north, north, east, east, right? I gave a north, north, east, east. Then in the second one, in this one, I went north, east, east, north, north, east, east, north. In the third one, I went north, east, northeast. In the fourth one, I went east, north, northeast. And fifth one, I went east, northeast, north. Sixth one, I went east, east, north, north. So these are all the possibilities that I went through. Now, do you see a pattern over here, right? And I'll explain that pattern to you, but really, if you didn't find the pattern, then take one or two more source and target points and then see what are the patterns that you can make out of here, okay? And one pattern you'll notice is I want to go from 1 to 3, 3, right? In all of the paths that we had exactly 2 ends and 2 easts, right? So I had 2 ends and 2 easts. I did not have any more paths than that, right? And so why is it that I had 2 north and 2 east in all of them, okay? And if I were to do 3, 3, 1, 1, I would get exact south and west also. So why is it that I got 2 north and 2 east in all of them? Well, let's see what's going on here. Let's say I move north here, right? In order for this y, that is I am currently at y of 1, in order for this y to reach to a y of 3, I need to be able to go north. No matter how many other moves I do in between, I need to somehow get this to north, and the only way that is possible to do is by 2 north movements. That's it. There is no other way. I don't have a south movement, I don't have a west movement. I can't even repeat moves here, right? Because the way to repeat moves would be to go forward and come back. So if I have to, like, let's say come back to A, I would have to go to north and come back to south. It's not possible. I can't move south. So once I moved north, that's it. I moved north, I can't come back ever. That's precisely the point here, because for example, let's say you're saying I go to 3, I can go to 4 and then come back to 3. You can't, because to do that you'd have to take a south. So to reach exactly B position, I need to increase my my y axis by 2, right? And that's only possible by taking 2 north steps. Similarly, to get my x coordinate of A to B, I have to again take 2 steps to the east. So I will have to take 2 steps to the east. Now, in which order I take them doesn't matter. As long as I take 2 steps to the north and 2 steps to the east, I will always reach B. That's it. Because the north contributes exactly to my y axis and my east contributes only and only to my x axis. Similarly, if I get a south, so my south contributes only to my y axis, and my east contributes my west contributes only to my x axis, right? So that is what we get over here in this scenario, that we need to use. Just by looking at 2 elements, we can very quickly say, so for example, I have a starting position of A, let's say 1, 2, and this has to go to, let's say, B, 10, 9, right? I can first of all say that the only way this is possible to do is if I am allowed to move east, because A is increasing by east, x axis is increasing by east, and I need a northeast at every time, right? And now the only way I can reach there is I need 9 norths. So I need 9 norths, and I need, sorry, not 9 norths, I need 7 norths, and I need 110, right? So I need 9 easts, right? The only way I can reach B is by doing 7 norths and 9 east. How I reach there, that is, do I do north first or east first or some of that? It doesn't matter which arrangement I do it, but as long as I got 7 north and 9 east, I can find out the number of ways I can do go at the end, right? So any combination of 7 norths and 9 easts, 7 norths to increase 2 to 9, and 9 east to increase 1 to 10, any combination of this will lead us to the northeast, to 10, 9, right? Now, that's the trick over here, any combination. So that means that totally I need to have a character, right? I need to have 7 into 9, 7 plus 9, that is, my path is always going to be of length 16, right? I'm going to have a path of length 16 is going to be there, and also the directions possible are 7 north, it has to be 7 north and 9 east, right? So if you look at over here also, what we have is we have the same thing. I can have 2 norths and 2 easts, and the number of the path length has to be 4, because it will be like 2 plus 2, right? So 2 norths, 2 easts needed. So we have over here 2 norths plus 2 east, right? So that's what we have over here, 2 norths plus 2 east, and we get 2 norths plus 2 east, which is the length of 4. So basically, this is no longer a 2D arrays question. This actually becomes a permutations and combination question. It just becomes, how can I construct a string of 7 norths and 9 east, or over here, like in this case, 2 norths and 2 east, okay, such that they are of length 4, obviously, but north and east are repeated. Or rather, how many ways are there of arranging north and east? How many ways are there of arranging north and east, or n and e, in a string of length 4, such that 2 norths and 2 easts are repeated, or 1 north is repeated and 1 east is repeated? And if you know the formula for this, it's very simple. So that is length factorial. So you'll have the length factorial divided by all of the repeats factorial, right? So here we have 2 factorial into 2 factorial. We'll have 2 factorial into 2 factorial. Why? Because the repeated numbers are north is repeated 2 times and east is repeated 2 times, and the length over here is the factorial. So you'll actually get 4 factorial by 2 factorial into 2 factorial, which is nothing but 4 into 3 into 2 into 1. So it's 4, 3, 2, 1 divided by 4. So 4 and 4 get cancelled, and so this becomes 6. So totally there are 6 ways of reaching, and that's what we got over here, 6 ways of reaching. Similarly, if you had to calculate for this, you don't need to do any complex backtracking or anything. It's simply 16 factorial divided by 7 factorial into 9 factorial, whatever that is. I am not calculating that now, but that is the number of ways that we are going to get 7 factorial into 9 factorial. 16 factorial by 7 factorial into 9 factorial, because those are the number of ways in which you can construct a path of length 16 such that 7 elements are repeated and another of the elements repeated are 9 elements are repeated. So that's basically the question. So the trick here was to understand that it's not a backtracking question. I don't have to construct all paths. I don't have to take the total of all paths. The previous question was a DP question, so some of you might have thought I have to do DP again over here. Not really. Probably if you want to save time in factorial, you can do some DP there, but really this is like an order 1 calculation here. This not order 1, sorry, but it's just like, you know, if you look at the constraints also, the constraints for this weren't really that much. So if I just go to the constraints, I think constraints weren't even given, so you can, yeah, constraints were given that up to 15. So really up to 15 factorial, it's not really that difficult to calculate. So you just have to calculate the factorial. So because I've almost anyway shown you the answer over here, I will be showing the question, at least my solution for this one, how we went about solving this question. And again, I did it in Python, but I've got a lot of requests asking, should we do it in Python? Should we not do it in Python? Should we do it in Java or C++? And really, it doesn't really matter which language you do it in. The language you are most comfortable with, you should pick that up. The only reason we are making some solutions in Python is many of Edyst students are in Python, but I recognize a lot of you are still not on Python, which is completely fine. If you are a Java student, earlier a lot of Edyst students used to be Java students, so we used to do the solutions in Java. It really doesn't matter if you understood the logic, then any language is completely fine. So I'll just show you the solution how we did it. So always when I'm calculating factorial, I like to create another function for factorial. I don't like to mix that with the regular logic. So this is the factorial part. And yes, you can do, like if you already know, so this is one tip to all of you, is that if you already know that the max is going to be 15, you can pre-compute all the factorials. You don't need to calculate all the factorials every time. Maybe not. I mean, see, in our case, for each test case, we are just doing a factorial calculation about 3 times. So it's not a big deal. But yeah, the best practice is you actually keep this, calculated beforehand, so that you don't get a time limit exceeded later on. But yeah, we made a function here. This is just going through all of the test cases. We took source and so target as test case. This is the direction that we have taken, and actually this entire code block is to check if it's even possible to reach that condition or not. So like I was saying, if the target y is greater than source y and it says that we have to go south, we are never going to reach that, because target y is greater than source y. It's above y, right? Above A's y, and so on. So we check all of those conditions. 1 second, let me just check if we are in the same place. Alright, great. Sorry for that. There was a slight problem there. Okay, anyway, so I'll just repeat what I was saying. So saying that this was the place where we were checking where south, north, east, west is what we were checking. Is there a shorter way to write this? Absolutely, there's a shorter way of writing it. But again, we are not in any hurry today. Hence, I did not write in a shorter way. So we calculate the absolute difference between the target and the source, and y also. We take the absolute difference between them. And like I said, this is the dist x plus dist y is the length of the path, and factorial of both of them are, so we take the factorial of that, and then we also take a factorial of each ways or each repetition. So dist x is you'll need these many east or wests, and dist y is these many norths or souths you will need. And if I run the test cases, we get this. So basically in this scenario 10 10 1 1, we can only go northeast. So while north is good for, north is not good, while east is also not good, we need to be able to go west, we need to go southwest, hence it's impossible. Similarly here, 3 7 5 3, while south is good, 7 to 3 is fine, but 3 to 5 I can't go, I need east, I can't go west, so hence it's impossible. And for 1 4 0 6, it'll just take, I need to go 6 minus 4 2 plus 1, so I need 3 as the path length. And so that will be 3 factorial divided by 2 factorial, because this will be 1 factorial. So 3 factorial divided by 2 factorial will be 3. Okay, so that's why it gave us this, and if I click submit, it passes all of the test cases, right? Okay, so that was this question. It wasn't too difficult if you spent a little bit of time thinking about it. And now that you've seen the question, I hope that any other time you get a question on something like this, you will think 2 times about doing the question instead of just going directly to a backtracking approach or something. The trick in any product based companies, interviews and all, is do enough questions and you'll start seeing patterns on your own, right? And then you'll be able to say, oh okay, I've seen this question before, this is how. So alright, so now we're here. Let's go to the next question. That is the last question for this daily challenges, and this question is called Batman's Jackpot. Okay, we kept Batman for the last because he seems to be a huge favorite for a lot of you. I didn't like the new Batman. I preferred the previous Batman, Christopher Nolan's Batman. But yeah, to each their own. This is a very old Batman. I hope you like the joke over here. Okay, alright, so the question is a pretty simple question if you know some basics of graphs. Okay, so I'll show you how you can go about solving the question, and yeah, then I'd express okay, before I go ahead, I just saw a very good question from Kishore. Kishore says, if source x and target y is equal, so if source x and target y is equal over here, right? Or rather, if source x, target x, and both of them are equal, then there is really no way of going there. So I think what the question says is, I think, or at least the question should say, all right, you need, if it's impossible, okay, yeah, so I think it'll always be possible to reach. I don't think x and y will be the same always. So x and y are not going to, rather, even if x and y are same, the source and target points will not always be the same. Okay, so that's something you have to assume in the question. And if they are the same, then it's going to be like what, 0 factorial by 0 factorial into 0 factorial, which is 1. So even that would have been an accepted answer. So thanks for that question, Kishore. Although that case is not there, but even 1 would have been a valid answer. It's not an issue. Right, so let's go to the Batman's Jackpot question. So in this question, it's basically like, I'm given a villain ID, okay, villain VI, and before I beat this villain VI, I need to be able to beat all of the other villains that this VI is dependent on. So it's like, if you played those old video games, there was this boss fight that used to be there, that you can't beat the boss unless you beat all of the previous henchmen before it. It's like, I don't know what is a good analogy today. Yeah, anyways, so I'm not getting a good example today, but yeah, it's like if you were even thinking about Batman, you'd probably want to beat Bane and Riddler and all of these before actually getting to the main one, Joker, right? So it's kind of like that. This question also has many variations. One of the variations of this question is that you're a manager, and as a manager, you can't finish all of the tasks until all of the previous tasks are finished. So how much time will it take for all of the tasks to finish completely? And I'll tell you a good trick on this question, but before that, let me just summarize the question again. So for example, this is the example input, and we'll copy this and we'll show you how you can go about solving this question. Okay. Right. So this is the Batman question, and here we have here. By the way, Batman is getting a lot of bad rep these days because of the bat connection. Yeah. Sad for bats and Batman. Anyways, so this is the number of test cases we have, number 1. So we'll leave that apart. We are told that there are going to be 6 villains, right? So we are supposed to beat 6 villains. So I'll take this part out also. And we are told that the first villain is not dependent on anyone. That's why it has 0 over here. The middle column here, so this middle column, this one, all of these middle columns are the time taken to beat this particular villain. So the time taken to beat the 6th villain is just 1 hour or minute or second, whatever unit of time you take. So that is the amount of time taken to beat this particular villain. And I'll just put it in different colors so that, you know, all of us have it, we have it pretty clear. So this is the time taken, 1 second, to beat the villain. And we have, yeah, here we go. Okay, so this is the time for this one, and now one of the mistakes somebody did while not understanding the question was, well, if I have to beat the 6th villain, the 6th villain can be beat in 1 hour. So the answer is 1, because the last villain takes 1 hour to beat, right? So that's not the question. The question is, how much time will it take till I finish all of these above, and then I get to 6. And actually speaking, if you just take a sum of all of them, that may also not be correct, because you would have to wait for some of them. So what do I mean by that? So for example, if I take the sum of the entire thing, what will I get? I'll get 5 plus 6, 11, plus 3, 14, plus 2, 16, then 17, then 18, right? So as per that, my thing is total time taken is 18, right? Whereas as per the question, if I go back to the question, so as per the question, the total time taken is actually 16. It's not really that much, it's 16. So where did those 2 seconds get eaten up? Let's look at the slides again. So basically we have these, this is the time taken. 1 I can get started on instantly. So I first start beating up 1. Once I finish beating up 1, after 5 minutes, go to 2. So I can start with 2, because 2 only depends on 1 over here. Okay, so I can go to 2. 2 is beaten after 6 minutes. So totally now after 11 minutes, rather cumulatively, 2 is beaten. Then I can start beating 3. So 3 is beaten after 14 minutes. Then I can start beating 4. And the best part is, the moment I beat 3, I can start beating 5 also, because 3 and 4 and 5 could not start till 3 is over. So while 5 does not depend on 4, moment 3 is over, I can start beating both of them together. So I have, I can beat 4 is beaten after 2 minutes, 4 is beaten after the 16th minute, and 5 is also beaten actually after the 15th minute itself, because you finish 3 after the 14th minute, right? So 3 was finished at the 14th minute, 4 is finished at the 16th minute, but 5 you could have just started right after 3 is finished. So 3 is finished after 14. So 5 is finished at 15. Now 6 depends on 1, 2 and 3. So that is 6 depends on 1 being finished, which was finished at the 5th minute itself. If actually 6 did not have any other dependents, right? If 6 did not have any other dependents, we would actually be done at 15, because the last one to be beat would be 5. But looks like 6 does have. So 6 needs 1 to be finished, 2 to be finished, and 3 to be finished, right? So okay, sorry, even then it will be 16, because 4 is the one that takes, we have to wait till the last villain is beat. Anyways, so let me just recap. Even if 6 was 1, we'll look at both the cases, if 6 was 1 or 6 was 1, 2, 3. So if let's say 6 is needs to beat just needs 1, 2, 3 to finish, that's like saying 6 just needs 3 to finish, because 3 itself needs 1, 2 to finish. So once 1, 2, 3 are finished, 4 can get started, 5 can get started, and actually 6 can also get started, and it also takes only 1 minute. So 6 takes 1 minute, is 6 is beat after the 15th minute itself, right? So 6 is beat after the 15th minute, but the last villain to be beat is the 4th villain, and that will take 16 minutes, right? So finally the answer to beat all the villains, not just the last one, but all the villains, is for 16 minutes overall. So basically, if at the end of the 16th minute, we will have all of the villains defeated. All right. So how do you go about solving this question? Well, there are a couple of approaches. One thing is, what happens if we just sort each other by the dependent IDs, right? So if we just started sorting each other, like how it's kind of sorted here by the dependent IDs anyways, right? So this depends on 0, therefore this goes first, that means it can start. This depends on 1, so 2 can finish, sorry, when 1 is finished, 2 can start. And so if I start sorting each other by dependent IDs, I will get it, except that it is possible that you can have multiple dependent IDs. So imagine if this one said that we have to wait for 3 to finish and we have to wait for 4 to finish. All of a sudden, our calculation goes off, right? Because earlier we were saying that you could run it parallelly, but now you can't run it parallelly because 4 also has to finish and then 5th can finish, right? So yeah, that is one of the big issues here, that I can't just sort it completely by the dependent ID. If there was only one dependent ID, I could have done that, but there are multiple dependent IDs, right? So one way you can go about it, and this is what I would like to sort of share with you on how you can solve this question, is this is a typical topological sort question. Now all of you will be like, what exactly is topological sort? Well, if you have a graph, okay, and it depends completely on the graph data structure. So if you have a graph here, and if you represent each villain as a node, okay, and you depend each and you treat each of these dependent IDs as another node to which it's connected. So for example, you have 1 which starts on its own, it does not depend on anything, but once 1 is done, I can start 2, right? And once 2 is done, I can start 3. So it's like a graph that you can only start, it's like there's an edge between 2 to 3. So there's a node 2, there's a node 3, there's an edge between 2 to 3. And just by going by this, even though in the question it was given like this, but in any case, let's just take this one. What we are saying is 3 has a graph to 4, has an edge to 4, and 3 also has an edge to 5. So you have 3 with an edge to 5 also. So if we have 3 with an edge to 5, and 4 also has an edge to 5. So there is, we'll put that here, 4 has an edge to 5 over here, right? And then say 1, 2 and 3. So 1, 2 and 3, each of them also have edges to 6, okay? If you do it like this, then you will be able to very quickly and easily visualize that 2 will only start after all its dependents are completed, and whatever is the time taken to complete the dependent, that is 2's start time. So 2's end time will be whatever was 1's end time plus 2's duration. So for example, 1's end time was 5, I take 2's duration as 6, and then 2 ends at 11. So that means 3 will be 11, which is 2's end time, plus whatever 3's duration is, which is 3. So it will become 14, right? So similarly, if I can figure this out, right, that is, if I create this nodes and and this is a very simple thing to do in graphs. It's nothing difficult. The only thing is you might find this difficult if you've never done graphs before. So if you've never done graphs, you'll find this difficult. And one of the funny things happens where a lot of students who've never done graphs start discovering graphs. So what they try to do is they try to see, oh, this question is basically, I have to find out, they'll try to formulate the graph question. Whereas if you knew graphs, then that algorithm already exists and you don't need to reinvent that algorithm. You just need to apply that algorithm. So similarly over here, representing these nodes as a graph is nothing new. If you know how to do it, you can pretty much do it. So one thing for you is to just go and pick up how to represent this as a graph. And then the second thing you have to do is just figure out what is the maximum time taken by each of my pre-nodes. So that is by each of my predecessors or each of the in degrees of my node. So for example, 6 is coming from 1, 2, 3. So until 1, 2 and 3 are finished, then 6 will not finish. Or what that basically means is I need to get 1, 2 and 3's end time. Each of them should have an end time, and only then will 6 get will I able to start 6. So I take, let's say 1 ends, let me just take this on a new page, 1 second. So for example, if it was something like this, right? So let's say 6 was ending at the end. So let's say 1 ends after end time for this is let's say end at 10 minutes, right? For 2, the end is at 20 minutes, let's say, and for 3, the end is at 40 minutes. Okay. Now 6 can only start at the 40th minute. So 6 can only start at the 40th minute, because even though 1 and 2 were ended, it still depends on 3. So unless 3 is finished, I can't really start 6. So 6 only only starts at the 40th minute. 40th minute. So for 6, it will be 40 plus duration of 6, right? That's what it will be. For 6, that is when 6 ends. And if there is something after 6, then that will depend on when 6 ends, and so on. So this again is not difficult to do in graphs. The only issue is, how do I know what is the time for 1, 2, 3? Do I do a recursive call for 1, 2, 3? Then I will find out that 3 is dependent on 2, and that 2 is dependent on 1, and so on. So it becomes a mess if you do it recursively, because especially if the graph is huge. That's why there is something called a topological sort. What a topological sort basically does is, one second, yeah. So what a topological sort does is, it sorts all of the elements as per the elements of the dependent IDs. So for example, it just basically says that you start with the one, you probably start with the source, and you know the source over here, right? You pretty much know the source over here, which is 1, because it has 0 dependent ID. You start with that, and then you start mapping out that unless 1 is finished, 2 can't start, unless 2 is finished, 3 can't start, and so on. So that your order of calculation is always correct. So what I mean to say is, first do read about graphs, and then try to sort it topologically. Once you do the topological sort, what you'll get is, for each node, from the starting node, update its start time and the max end time, right? So whatever is the start and end time of that, updated. And if you've done that, if you access each of them topologically, that means if you access each of them in the order in which they finish, then you will be able to get their end times properly. Otherwise, what will happen is, I'm here, right? I'm trying to calculate the end time for 6, but for that I need to find out the end time for 1, 2, and 3. And each of them could have dependent IDs of their own, could have certain villains that they're dependent on. So let's say 1 and 2 I found, but 3 I can only find after 4 and 5 is finished. Well, I should have actually calculated 4 and 5 first and then come to 3, right? If I wait for 3 to be calculated, I don't know when I'll get 3 back, because I have to maintain a track of, oh, first calculate 4, 5, then calculate 3. And that track is maintained for us through something called a topological sort, right? So that's what this question is all about. If you somehow figure out the topological sort of this, then this becomes very easy to do, and that's what you're supposed to do. Just take, once you're topologically sorted, start a time, the end time of the start time of this node. So the end time, sorry, the start time of this particular node, that is 6, is the maximum end time of any of the dependent IDs. So 3 is the 3 has the maximum end time, which is 40 minutes. Therefore 6 will start at 40, and then the end time of 6 will be the duration of 6. We do that for each node. And just one thing for all of you, while this is a question that could very easily be asked by Amazon, I have seen topological sort type questions being asked by Amazon. That's what we had said over here, that it is an Amazon question, and that's very true. So just give me 1 minute, 1 second. Alright, so while this is the type of question that probably could be asked on, by Amazon and all of that, so there is another place where this question was asked, and this question was asked in CodeVita 2019 round 2. So it was for more of a product based question, and this is actually the entire webinar that we did last year, 2019, and this question very similar, even the test case are quite similar, are there. So if you would have seen this webinar, you have got a pretty decent understanding, and here I actually share how you can go about solving the questions using graphs, how to actually form a graph, and the actual the whole code is given there. So yeah, you can actually look at this video here, and that's why I say that if you really want to prepare for CodeVita and any of the product companies, because again, this question is, I have seen it on Amazon also, so it's not very specific to CodeVita only. So if you want to prepare for this, take out the time and start with this. Sorry, I think I got disconnected, but yeah, what I was saying was, this is the CodeVita course where you can start preparing for this, where we have both round 1 and round 2 questions, and This is the course where you can get more about Hack with Infi, bit.ly/Edyst_CCP. So yes, as I said, today there wasn't, it wasn't a really long webinar as the two prior days because we were only discussing 2 questions. If you like this webinar, please let us know in the comment below. Please also hit that like button so that we know that you liked this webinar. Subscribe to this channel and follow the Telegram channel because we will be launching May daily challenges. And so to be aware of the May daily challenges as well. And yes, we are launching a few new things so that you can get started right away. Yep, that's it. I'll just look at the chat now if you have any questions that I have unanswered. So I'll look at the chat and then we can just call it a day. So thanks, sir, for your solid effort. Thank you, Srivastav, for being online today and being so enthusiastic about coding. Really happy to see students like you. All right. Okay, somebody's asking about machine learning. Yes, machine learning is important, but what is really important is the basics. So try learning basics like Python first, and then you can pick up machine learning. I see a lot, not that it's not important, it's just that I see a lot of students, they do a 1 week machine learning course, they do a 1 week deep learning course without the basics of Python. And so when the interviewer asks something very simple like, can you sort this array in order n log n time? They are not able to answer, and so the interviewer doesn't even ask the machine learning question because they don't know the basics of Python. So go and first, if you want to pick up machine learning, go first learn the basics of Python, then go ahead for things like machine learning. Kishore had a question which I had already answered. Solid. So that's mainly it for today. Thanks everybody for joining in. I hope you have a great weekend in this lockdown time, weekdays, weekend, all of them look the same. But I hope you have a great weekend. Get some rest. I hope your families are safe. Thanks everybody for joining. Satish says, great sir explanation. Thanks Satish for being online, for checking out the video. And that's it from our side. Thank you so much for being here everybody, and we'll see you all next time. Next week, stay tuned. We are going to do webinars on CodeVita and Hack with Infi. So yeah, be prepared. We'll see you all next time. Thank you so much, and have a great weekend. Thank you.